This is a walkthrough of the A-level paper 3, which is on statistics and mechanics. Question 1. Caf coffee is sold in packets. A seller measures the masses of the contents of a random sample of 90 packets of Caf coffee from her stock. The results are shown in the table below. So we've got grouped masses here, we've got the midpoint of each mass here in this column, and we've got the frequency in the last column. Then it says here you may assume that the sum of Fy squared is this, I think it's 5,644,171.5. This is what we call a summary statistic. So this is where the summary of a calculation is given, and it will normally save us some time. A histogram is drawn with the classes 245 to 248, and that is represented by a rectangle of width 1.2 and height 10 centimeters. Part A, calculate the width and height of the rectangle represent the class 255 to 260. So let me just highlight those bits of information from the table. So the 245 to 248, that's this row here, and I can see that has a frequency of 15. And the 255 to 260, that's the last row there, and that has a frequency of 9. Now there are different ways of doing this question, but I'm going to be using ratios. So let's start with the one that I've highlighted in red. The actual class width here, so the difference between 245 and 248 is 3. Now notice that the groups continue from one number to the next, so I don't need to add or subtract 0.5 to the edge of the groups to close them up. So the one that I have has a width, an actual width of, or class width of 3, and that is represented by an actual measured width of 1.2. Now that ratio will be the same whichever bar you look at. So if I look at the bar that goes from 255 to 260, that has a class width of 5 divided by an actual width, and that's what we need to find. Let's call that x. So to summarise what I've done the class width divided by the actual width, and that ratio is the same whichever bar you look at. So let's cross multiply, and that will give me 3x is equal to 5 times by 1.2. From there I can easily find x. That's going to be 5 times 1.2. Let's do that, 5 times 1.2. And that gives me 6, and then divide that by 3. So I get 2. Right, so I can write down the width is 2 centimeters. So don't just leave it as 2. Put width equals 3 centimeters. Now I'm going to do that same type of ratio type calculation for the heights of the bars. Now I've got the actual measured height, the actual height, but I don't have like the frequency density. That's going to give me the height that I'm using. So I want the frequency density to get the height. Now remember, to find a frequency density, we do the frequency, which is proportional to the area, divided by the width. So I need to do for this one 15 divided by 3, so I get a frequency density of 5. And then for the bottom one here, I've got a frequency of 9 divided by 5, so I'll just leave that as 9 over 5. Let's see if that gives me a nice number that I can, like decimal, that I can use. Yeah, 1.8, so we'll use 1.8. So we're going to do the same thing again. So it's going to be the frequency density. So it's a very similar calculation to the other one. Frequency density, which is like the height we're going to use, divided by the actual height. So starting with the bar that we know, which is the bar which is the 245 to 248, that has a frequency density of 5 and an actual height of 10. the bar that we want to find the height of has a actual height or a frequency density of 1.8, 9 divided by 5, divided by the height that we want to find in centimeters. So again, we can solve this by cross multiplying. So this will give me 5x is equal to 10 times by 1.8. So from here I can do 5 times by 1.8 and divide that by, 10 times by 1.8, which is 18, and do 18 divided by 5. Okay, 18 over 5, which is 3.6 centimeters. So that means that my height is 3.6 centimeters. Now, as I said, there are other ways of doing it, but I just find this way the most helpful way of doing it. Moving on to part B, use linear interpolation to estimate the median mass of the contents of a packet of calf coffee to 1 decimal place. Now the first thing we need to do is to locate the class the median is in. And the median is Q2, so we'll use Q2. So locate the class of Q2. So to do that, we're going to need cumulative frequency and also do a calculation to work out roughly the position of the median. Now, if you've got a sample of 90, I can either do half n plus 1 or half n. I'm going to use half n plus 1. That gives me the exact position. But when the frequency is large-ish, that's about 90, then you can use either half n plus 1 that I've used, or half n to locate the position. Right, so that's going to give me half of 91, which is 45.5. So that's telling me that the median is the 45th number. Let's do the cumulative frequency and see where we find the 45th number. So we've got 8, then up to 23, and then 23 plus 35 is going to be 58. Plus 23 is going to be, let's see, add 20 to that, it's going to be 78. Plus 3, 81, and then 90. Right, so the 45th number is going to be in this third group here, 248 to 252. So let's just highlight that so I don't miss anything out. Right, so this is where I'm going to find the median, somewhere in this group here. So I'm now going to do like a little number line to help me do that calculation. So this bar basically represents the class that goes from 248 to 252, and its frequency is going to go from the frequency where the last group finished, which is 23, up to the frequency which is at the end of that group, which is 58. Now I know the frequency of my middle number, and that's 45.5, and I want to find this value here, that missing value. I know we're using x's for all of these, but you know they're all different. So I can, like the previous bit, I can use ratios to help me work out what this value, or to estimate this value here. Well, I'll find the exact value, but what I'm actually doing is estimating the median. So I'm going to do this width here divided by this width here all the way across there. So if I do that, I will get x minus 248 over 252 minus 248 is equal to, and I'll do the corresponding bits at the bottom, 45.5 minus 23 divided by 58 minus 23. Now I could use any sort of whips I want to do this, but I'm choosing the one where I just get the x appear once, and doing it in such a way that it just makes it easier to find a value of x and make x the subject. Right, so let's work out what we get. 252 divided by minus 248 is 4, and then 45.5, or it'll be 45 if you use half one, so half n, sorry, so 45.5 minus 23 divided by 58 minus 23, that's 9 over 14. So that's easy enough to solve for x. Let's see what we get. So I'll take that 9 over 14, times it by 4, add 248, and I get 250.571, and so on. I want to give that answer to, now it says we need to give it to one decimal place, so it's going to be 250.6. 250.6 rounded to one decimal place. Now if you used half n instead to locate your median, this would have been 45, this would have been 45. All of this calculation here would have given you 22 over 35, so slightly different, and your answer rounded to one decimal place would have been 250.5 instead of 250.6. The mark scheme allows you to use either half n plus 1 or half n. I just use half n plus 1, just personal preference. And moving on to part C. Estimate the mean and the standard deviation of the mass of the contents of a packet of calf coffee to one decimal place. Now the quickest way to calculate the mean, and this is a mean of a sample, so we shouldn't really use the mu symbol, that's reserved for the mean of a population. So use, we've got y, so it's going to be y bar rather than an x bar. Yeah, so yeah, using a calculator, so you want to go into your statistics menu, a one variable calculation, make sure your frequency is switched on, type in the values into the table, and then you can pick up all the values for the mean, sum of x squared, and so on. And I've got the mean as 250.39, and this is what comes up on my calculator. Because we want to give it to one decimal place, it will be 250.4. So without doing anything else, I can see actually that my mean is fairly close to the median there. Might be using that later on. So that's just an observation until we get on to the next part of questions. And then we want to find the standard deviation. Okay, so the standard deviation is going to be equal to the sum of fy squared, okay, which is given. So that's 5644171.75, and that's actually exactly the same as what I've got on my calculator for the sum of x squared, then divided by the sum of f, which is 90, and then I subtract the mean squared. Now I want to use the exact value rather than my rounded value, so that was the 250.3944, so on. So that's the number I'm going to be using just to make sure that I'm being as accurate as I can. Right, so on my calculator it gives me 3.9549, so on. But when I did the mean calculation on the same screen, it also gave me the standard deviation as 3.95495. So it comes up as the same number. But don't just write down the answer on your calculator. You do need to show the work in. I changed that to y, that I'd put x in correctly. I need to give my answer to one decimal place. So that's going to be 4.0, isn't it, if I round that? Because the 5 will make the 9 go up here. So 4.0 is going to be my standard deviation. Now, I guess strictly speaking, because this is the standard deviation of a sample, I shouldn't be using this sigma either. I should be using S for the standard deviation of a sample. So 4.0, and again that's to 1 decimal place. So let's highlight that, and this as well. Part C. The seller states that the mean mass of the contents of the packets is more than the stated mass. Okay, so let's just highlight that, more than the stated mass. Given that the stated mass of the contents of a packet of calf coffee is 250 grams, so that's the stated mass, and the actual standard deviation of the contents of a packet of calf coffee is 4 grams. Okay, and that's pretty much what we had worked out for the mean and the standard deviation. We need to test at the 5% significance level whether or not the seller's claim is justified. Stating your hypothesis clearly, you may assume that the mass of the contents of a packet is normally distributed. So this is a full hypothesis test, and whenever we do any hypothesis test, we start with H0 and H1. Because we're testing for the mean, we always use the mu symbol, and H0 is that the mean weight is just 250 grams. H1 is going to be that the mean is, and we highlighted it here, more than 250 grams. So that tells us an upper tail test. Next, I draw a normal distribution. I just do this because it helps me, for the sample mean. So they used Y, so I'm going to use Y. Okay, so there's my normal distribution. The mean of the samples is equal to the mean of the population, so that's 250. And the standard deviation of the samples is equal to the standard deviation of the population 4 divided by the square root of the sample size. Now, going back to the previous part of the question, that was 90, wasn't it? They looked at 90 packets. So I always like to write down what this model is, any type of distribution. So my model is that the sample means are normally distributed with a mean of 250 and a variance of 4 squared over 90. Always good practice to write down what your model is. It's an upper tail test, so I'm going to have a line over here, and from my sample the mean was 250.4. that was what I'd worked out in part C. I'm going to work out this area here and compare it to 5%. The other way is that you work out the area above 5%, find that critical value and compare it to 250.4. So my calculation is going to be this. Since it's an upper tail test, I want to find the value of the mean that's greater than 250.4. In other words, find that area. So that I can work out on my calculator. You may be more used to seeing this as the probability that the sample mean is greater than that. So I'd put in on normal CD a lower value of 250.4 at any large upper value, as long as it's more than, I think it's 5 standard deviations bigger than this. I just put in 9999999. A standard deviation of 4 divided by the square root of 90. Just type that in, your calculator will work that out for you. And a mean of 250, and that gives me an area of 0.17139 and so on. Okay, so that's this area here. Now that means that an area of 5% would be here. This area is 5%. That means that the 250.4 is not in the critical region. So I'll write that down. So 250.4 not in critical region. And why is it not in the critical region? Because our area, and we need to state this, 0.17139 so on is greater than our 5%. So if it's not in a critical region, that means that we accept H0, and then always finish with your conclusion. Therefore, there is insufficient evidence. So always look at what you are trying to answer, and that is what is the seller's claim. So the seller claims that the mean mass of the contents of the packets is more than stated aim. So we can just say there is insufficient evidence to support, we don't need to write the whole thing out again, to support the seller's claim. Why is there insufficient evidence to support their claim? They claimed that the mean mass of the packets is more than the stated claim. If it was, this 250.4 would be in here in that 5% area in the critical region. It's not. So where we can be confident in our calculations that actually it's not more than the stated claim or stated value. And lastly, part E, we'll do that up here. So part E, using your answer to part B and C, comment on the assumption that the mass of the contents of the packet is normally distributed. Now, what's special about a normal distribution is that the median, that's Q2, the mode and the mean are all equal. Now, what did we get for our median? Q2, we got 250.6, and for our mean we got 250.4. They're pretty close, aren't they? And because they're pretty close, we can be confident that the data that we have is normally distributed. So I'll put something like, since the median is close to the mean, the data is, well, not 100% sure it is, but we can be sure it is normally distributed. The key thing is that we mention the fact about this mean and median being quite close in value. Question 2. A researcher believes that there is a linear relationship between daily mean temperature and daily total rainfall. The 7 places in the northern hemisphere from the large data set are used. The mean of the daily mean temperature T and the mean of the daily total rainfall S for the total month of July in 2015 are shown on the scatter diagram below, and that's this diagram here. So T for temperature and S for the rainfall. And before I even answer the question, I'm looking at it, I can see maybe a positive correlation. These two look like outliers, so maybe if I took those out, it's looking like a negative correlation if those are taken out. And they're labelled, so maybe I need to make some comment about these two in a moment. Anyway, part A. With reference to the scatter diagram, explain why a linear regression model may not be suitable for the relationship between T and S. So my answer is basically going to be what I was just talking about before when I was just looking at the scatter diagram. With the points G and H, there appears to be a weak positive correlation, and without G and H, the correlation appears to be negative, so a linear regression model may not be suitable. I mean, you could actually say that even when I've said positive correlation, they're not really on a straight line, are they? You've got this big gap between the two. There seems to be like something going on here and something going on here, like two almost separate sets of data. So yeah, it would be difficult to justify the use of a linear regression model. Okay, part B. The observer calculated the product moment correlation coefficient, the PMCC, for the 7 places and obtained 0.658. Part B. Stating your hypothesis clearly, test at the 10% level of significance whether or not the PMCC for the population is greater than 0. So this is a hypothesis test for 0 correlation. So H0 is always going to be that the PMCC for the population is 0, so rho is equal to 0, and then the value of rho we're testing to see if it's greater than 0, so we're testing to see is rho greater than 0. Is there some sort of correlation there? Now for this one we don't need to do a calculation, we just look up in the formula book for the critical value. So you find the appropriate page in the formula book, you go across to the 10% column and you go down to a value of n equal to 7, yeah, because we had a sample of 7, and that will give us a critical value of 0.5509. So there's our critical value. These types of questions I like to draw a number line showing my values of R, and that's going to go from 1 to -1 with 0 in the middle. I put my critical value on, and my critical value is 0.5509. There'd also be the corresponding negative, and my critical region is here, the 2 tails. That's where I'd reject H0. I look at my value of R, 0.658, and 0.658 is going to be over here. Okay, so it's in the critical region, R equal to 0.658. So we'll say that since 0.5509 is less than 0.658, okay, our value of R is in the critical region, so we reject H0 and then we write our sentence in context. Therefore there is sufficient evidence for what? Sufficient evidence that the PMCC for the population is greater than 0. Sufficient evidence that the PMCC for the population is greater than 0. So just say whatever they say in the question. Part C. Using your knowledge of the large data set, suggest the names of the 2 places labelled G and H. Now, the question did say that all of these places are in the northern hemisphere, so they're either in the UK, China or Florida. The only location in the southern hemisphere is Perth in Australia, and it's not one of those. So we have UK locations, we have Beijing in China, and we have Jacksonville in Florida. So it must be that these 2 places, they have a very different climate to the UK. Well, not completely different, I suppose. Beijing is similar, but it gets way colder in the winter and it gets much hotter in the summer, and where they're placed, their geography, their proximity to large oceans is completely different to the UK. Their landscape is different. So I would suggest that G and H would be Beijing and Jacksonville. Part D. Using your knowledge from a large data set and with reference to the two locations labelled G and H, which I've suggested are Beijing and Jacksonville, give a reason why these places have the highest temperatures in July. Well, both of these places are further south than the UK locations, so they're closer to the equator. So I'll just put further south. I put therefore closer to the equator, and these were taken in July, weren't they? And in July we'd expect them to have warmer temperatures in the UK, in the northern hemisphere, even though they're further south, still in the northern hemisphere. So further south, therefore closest equator, therefore will have higher temperatures in July. And lastly, part E suggests how you could make better use of a large data set to investigate the relationship between daily mean temperature and daily total rainfall. So my suggestion would be pick somewhere where you can investigate just one climate rather than a worldwide climate. So rather than trying to look for a correlation in places that have completely different climates, pick one place. Even within the UK, different locations have different climates. Sort of northern Scotland, Western Isles, northern England, southeast England, Wales, they all have different climates. So my suggestion would be that you just pick one location. Wherever that location is, just pick that one location and use the data from that place. Question 3. For a particular type of bulb, 36% grow into plants with blue flowers and a remainder grow into plants with white flowers. Bulbs are sold in mixed bags of 40. Russell selects a random sample of 5 bags of bulbs. Part A. Find the probability that fewer than 2 of these bags will contain more bulbs that grow into plants with blue flowers than grow into plants with white flowers. Now there's a lot going on here, so let me try and explain what's going on. We've got information about a single bag. So in a single bag, I'm expecting 36% to grow into plants, the bulbs, 36% of the plants will grow into blue flowers, and in a single bag there are 40 bulbs. So I'm only talking about single bags at the moment. And then in the question, in a single bag, what Russell wants is that more bulbs grow into plants with blue flowers that grow into plants with white flowers. So let me start with that information first. What's going on in a single bag? So I'm going to use the letter A to stand for the number of bulbs that become blue flowers in a single bag. And everything I've underlined in red is to do with a single bag. Now that's going to be a binomial distribution. So this letter A that I've defined, my random variable, is a binomial distribution. In a single bag there are 40 bulbs. The probability that it's going to become a blue flower is 36%. And I want to find the probability that more in a single bag grow into blue flowers than white flowers. So if in a single bag there are 40, more than half means more are going to be blue. So more than 20 means that more of them are going to become blue. So the probability that it's more than 20 is 1 minus the probability that it's 1 minus probability A is less than or equal to 20. So I'll work this out on a calculator. So we get 1 minus 0.9759 and so on. So let's do 1 minus that, and that is 0.02400. So we can pretty much say that it's 2.4%. Okay, so what we've got here, and I'll highlight that answer, this is not the final answer, is the probability that more in a single bag, more of them are going to germinate blue or become blue. Right, so now we're going to be looking at the 5 bags. So B, this is my next random variable, will stand for basically the number of bags. I'm not going to write the whole thing out, but basically a number of bags. So B, maybe I should have used a different letter because I'm going to have B for binomial as well, but never mind. So B is binomially distributed. This time the number of bags is 5, or my sample size is 5, and the probability that I'm going to get more of them become blue is this probability that I worked out here, and that's going to be that 2.4%, so it's 0.24, and I want to find a probability that fewer than 2 of these bags. Okay, so let's underline that in a different color. So everything I'm underlined in blue here is to do with the single bag. So probability that fewer than 2, well, that's the probability that it's less than or equal to 1. We can work that out on our calculator, and that gives me 0.99450. Okay, we'll give an answer to 3 significant figures. That's the norm. So 0.995 would be the probability of that. And you often get these questions where you need to do binomial twice, or you do binomial or normal once, and then that is then used in a second application of the same or a different distribution. Part B. So Maggie takes a random sample of N bulbs. Using a normal approximation, the probability that more than 244 of these N bulbs will grow into blue flowers is 0.0521, to 4 decimal places. Find the value of N. Right, so let's highlight what we've got. So our sample size is N. We need to do a normal approximation. It's more than 244, and we know basically what the answer is. We know what the probability is, and I guess we're sort of working backwards to find N. So first thing, I'm going to be using the letter C in this part. So this is going to be basically a probability, or I've got like the number of flowers in this particular case. I'm not going to write out the actual what it stands for. Just be aware I'm using the letter C. So first of all, if it was a binomial question, I'd have N. The probability it becomes a blue flower is the 36%, 0.36. I'm using a normal approximation. So remember, with a normal approximation, the mean is N times P, and the variance is N times P times by 1 minus P. Right, so my mean is going to be N times by P, so that's 0.36N. And then my variance is going to be this, which is NP times by 1 minus P. In other words, this times by 0.64, and that will give me 0.2304N. Now the next thing that we need to do, and this is often forgotten about, is any time that we do a normal approximation, we need to do a continuity correction. So here we've got more than 244. So the way that I do this, I draw a number line. To the right is increasing. I'll put 244 on there. So that represents this. I want to show more than 244. Now my little technique is, if it's more than symbol or less than symbol, you basically go into the line and make it shorter by 0.5. So that will take me to 244.5. So using my normal approximation, that means my probability becomes finding the probability that C is greater than or equal to, it doesn't matter because it's a continuous distribution, is greater than or greater than equal to 244.5. Now we'd normally work this out on a calculator, but we can't because we've got these ends where the mean and the variance are. So we're going to have to standardize this, and the way that we standardize it is by using the formula Z is equal to X minus the mean over the standard deviation. I want to find out what this Z value is. Now Z values, even though the mean and the variance change and the value on our horizontal axis changes, the actual area does not change. So the area on this is going to be the same as the area in the question. So more than 244, more than a Z value, is an area of 0.0521. So let me shade in that area, and I know that that area there is 0.0521. And I want to work out what this Z value is. So I can do that on my calculator by doing inverse normal. Now remember, when you do inverse normal, we want the area from the left. So I want this area here, unless you've got a graphic calculator, CG50, where you can specify left or right tail. So for area, I'll do 1 minus 0.0521, which is 0.9479. The variance as 1, standard deviation as 1, the mean as 0, and that will give me a Z value equal to 1.62482 and so on. So there's my Z value. So 1.62482 and so on is equal to my X value, which is 244.5, minus the mean, well that's 0.36n, divided by the standard deviation. So don't forget to square root it, square root of 0.2304n. Now I want to solve for n, so I guess the first thing I'll do at the bottom here is to change this into the square root of 0.2304 and then root n. I can work out the square root of this, so let's do that. And that's 0.48, so let's get rid of this here, and we can basically write this as 0.48 root n. Right, so if I now multiply both sides by this 0.4 root n, that will give me 0.77991 root n is equal to 244.5 minus 0.36n. Now I can't make n the subject, but what I can do is turn this into something that looks a bit like a quadratic. So that will give me 0.36n plus this 0.7791 root n, and then minus 244.5 equals 0. Now I know I've got n here and root n, but we could basically treat it like a quadratic, and we can do that if we think of this n here as root n squared, and that gives us the quadratic, so when I solve this on my calculator, it's going to give me the value of root n. Okay, so that basically gives me root n is equal to 25.0001. So we might as well pretty much just call it 25. And then the other value is negative, so we'll just forget about that. So, oh, and I corrected that as well. I don't know why I put n there. That should have been squared. So n is going to be equal to pretty much 25 squared, which is 625. Okay, so for this all to work and to get this probability, we need to have taken a sample of 625 bulbs. Question 4. The Venn diagram shows the probabilities of students' lunch boxes containing a drink, sandwiches and a chocolate bar. D is the event that the lunchbox contains a drink. S is the event that the lunchbox contains sandwiches. C is the event that lunchbox contains a chocolate bar. U, V and W are probabilities. Part A, what we need to do is to write down the probability of S and not D. So I'm going to use shading to help me with this. So it's the probability of S. So I'll shade that. There's the probability of S. And not D. So I want to shade not D and I want to find the overlap of those two. So let's do it in a color that's not going to make everything disappear. So not D basically is going to be everything that's outside of D here, like that. And I want to find where those two overlap. And can you see there is no overlap? So S and not D are actually mutually exclusive, which means that the actual probability there is 0. Part B. One day 80 students each bring in a lunchbox. Given that all 80 students lunchboxes, or given that all 80 lunchboxes contain sandwiches and a drink, what we want to do is to estimate how many of these 80 lunchboxes will contain a chocolate bar. Now this is a conditional probability question because it says given that. Now remember, the phrase that comes straight after the given that is the thing that you write straight after the line, and the thing that we're trying to find a probability of is the one that goes before the line. So let's write down what we've got here. So it says given that, so there's my given that. All 80 lunchboxes contain sandwiches and a drink. Sandwiches and a drink is going to be the probability sandwiches and a drink that goes there. And estimate how many of these 80 lunchboxes will contain a chocolate bar. So the probability that it contains a chocolate bar, because we're estimating the number of something, we need to take that probability and multiply it by 80. Now, as a reminder, this is the formula here for conditional probability. So the first part of our probability, the bit that goes at the top is like A and B, it's C and C and D. So let me write that down. So it's the probability of C and, sorry, not C and D, S and D. That's the probability of everything, isn't it? Over the probability of S and D. Now when I mean the probability of everything, it's basically the probability of C and S and D, or S and D and C as well. Now on my Venn diagram, that's here. See this bit here is S and D and C, and that is 0.27, so it goes at the top. The probability is S and D, so S and D is just this here, so it's both of those put together. 0.33 plus 0.27, that's S and D, and 0.33 plus 0.27 is 0.6. That's a bit like 27 over 60. You can leave it like that if you want to. You don't need to simplify it. And remember, we do need to times this by 80, don't we? Because that's just a probability. It needs to be times by 80 because it's something out of 80. So 27 over 60 times by 80, let's see what that gives us. And that's 36. So 36 lunch boxes. Righty, part C. Given that the events S and C are independent, let's highlight that, S and C are independent, and that the probability of D given C is 14 over 15, what we want to do is to find the value of U and the value of V and the value of W. Now, 3 unknowns means 3 equations. One equation, let's start with the obvious, is that the sum of the probabilities is equal to 1. So if we add everything together, so 0.33 plus 0.27, which is 0.6, plus everything else, which is going to be V plus W plus U, that's going to equal 1. So we can basically take away 0.6 from both sides, and we'll have V plus W plus U is equal to 0.4. So there I have my first equation. Then I'll use this extra information here. The events S and C are independent. So if S and C are independent, that means the probability of S, which is 0.6, times by the probability of C. Now C is going to be 0.7 plus V plus U, 0.27 plus V plus U, is equal to the overlap of those two, which is 0.27. So let's tidy that up a bit. So 0.6 times by 0.27 will give me 0.162. So 0.162 plus 0.6V plus 0.6U is equal to 0.27. I basically want to write it in a similar format to what we've got here. So that will be 0.6V plus 0.6U, and that's going to be 0.27 minus 0.162, and that leaves me with 0.108. And to tidy it up even more, I can divide both sides by 0.6, and that will give me V plus U is equal to 0.18. So that's quite nice, that one. So there's our next one. Then we'll use this piece of information here, that the probability of D given C is 14 over 15. So what that means is that the probability of D and C over the probability of C is equal to 14 over 15. Right, what do we know? Probability of D and C. So D and C, that is this part, that's the overlap of D and C. So that is going to be 0.27 plus V over the probability of C. Well, that's all of these added together. So 0.27 plus V plus U, and that is equal to 14 over 15. If I cross multiply, I will get 4.05 plus 15V is equal to 3.78 plus 14V plus 14U. Again, I want to write it in a form that matches up with the previous one so that I can easily solve this on my calculator. So taking away 14V from both sides will just leave me with V, and then taking away 14U from both sides will just leave me minus 14U is going to be equal to 3.78 minus 4.05, and that gives me negative 0.27. Okay, and solve this on my calculator. It gives me U is equal to 3 over 100, which is 0.03. It gives me V equal to 3 over 20, which is 0.15. And it gives me W equal to 11 over 50, which is 0.22. So those are my 3 answers. So yeah, I would just solve it on a calculator, especially as you have 3 unknowns. You could do it manually, but I think a calculator is probably a little bit quicker in this case. Question 5. The lifetimes of batteries sold by Company X are normally distributed with a mean of 150 hours and a standard deviation of 25 hours. A box contains 12 batteries from Company X. Find the expected number of these batteries that have a lifetime of more than 160 hours. So we know that for each battery it has a mean time of 150 hours, a standard deviation 25. They're normally distributed. Okay, that's for a single battery, and then we're looking at a box of 12 batteries, and we need to find the expected number of these batteries that have a lifetime of more than 160. As soon as you see that phrase, find the expected number, that means you're going to be doing some calculation times by your probability. Now in this case it's going to be 12 because there's 12 batteries. So it's going to be 12 times by our probability, and we are going to be working at that probability using our calculator and normal distribution. Okay. So I'll just use the letter X since they're talking about Company X. It's normally distributed. The mean is 150. The standard deviation is 25, so the variance is 25 squared. We want to find a probability that a single battery will have a lifetime more than 160. So we can do this on a calculator. You don't need to do 1 minus anything, because remember, normal distribution is continuous. So let's go to the distribution menu. We'll do normal CD, a lower value of 160, an upper value, just put in something very big, standard deviation 25, mean 150, and that gives me an answer of 0.34457 and so on. That's for a single battery. We're talking about a box that contains 12, so I need to take that number, that 0.34457 and so on, times that by 12 and see what I get. That's 4.1349 and so on. We want to give an answer to 3 significant figures, so 4.13. Okay. Part B. Right, the lifetimes of batteries sold by Company Y are also normally distributed. They have a mean of 160, and 80% of these batteries have a lifetime less than 180 hours. What we want to do is to find the standard deviation of the lifetime of these batteries from Company Y. Because we're trying to find the standard deviation, it does need to be standardized. So what we have is Company Y, normally distributed, a mean of 160, and an unknown standard deviation. And we also know that the probability that one of these batteries has a lifetime less than 180 is equal to 80%, or 0.8. So because we need to standardize, I'll draw out my standardized normal distribution, and I know less than this value of Z which I want to find, that area is 80%. So I can use inverse normal to work out this Z value here. And that gives me a Z value of 0.8416. So 16. 2, and so on. I can now use that formula that I use for standardizing, which is Z is equal to X minus the mean over the standard deviation. So the equivalent Z value is 0.8416, probably that would be enough, is equal to the corresponding unstandardized value, that's 180, minus the mean, which is 160, divided by this standard deviation, which we're trying to find. So we can rearrange this and solve for the standard deviation. So I will have 0.84162 times by sigma is equal to 20, and that will give me sigma equal to 23.763 and so on, 3 significant figures. So we'll do 23.8 as our answer for the standard deviation. Part C. Both companies sell their batteries for the same price. State which company you would recommend. Give reasons for your answer. So I'm just going to draw a little table for company X and company Y, and what their mean is and what their standard deviation is. Right, so if I start with company X, that has a mean of 150 and a standard deviation of 25 hours. Whoops, 25 down there. If I look at company Y, that has a mean of 160 and that has a standard deviation that we've calculated as 23.8. Now I can see that both have a similar standard deviation, so I'll just write standard deviation. Standard deviations are similar. However, can you see that company X has a higher mean? I would say this is significantly different. It's a difference of 10. That's a difference of 1.2. I guess we could look at the percentage difference actually, but yeah, we can just write down standard deviations are similar. However, the mean of company Y is higher, so I would recommend company Y. Company Y. Question 6. A particle P moves with constant acceleration I minus 2j, so let's highlight that. Acceleration, constant acceleration. So as soon as I see constant acceleration, I need to be thinking about CVAT. This is not differentiation or integration or calculus. At time t equals 0 seconds, the particle is at point A with position vector 2i plus 5j. So let's highlight that. So when t is 0, its position is 2i plus 5j and is moving with velocity u. So this is also at t equals 0. At t equals 3 seconds, P is at the point B with position vector negative 2i plus 8j, and we need to find u. So I'll just highlight that. So when t is 3, it's now at a different position at point B. So in this question, we're given the position when t equals 0. So I'll write that down. So when t equals 0, the position is 2, 5. I'm going to write it in a column like that. And then when t is equal to 3, the particle is now at the position negative 2.58. And to do this question, we need to work out the displacement that's taken place in those 3 seconds. Now, since we're dealing with vectors, we'll use r, and to work out the displacement, one way to do it is to work out the jump from the first position to the second, or to do the second minus the first. So if I do the jump, so I'm going from 2 to minus 2.5. So that is a jump of negative 5.5 or 4.5. Negative 4.5. And the jump in the J position, well, that's gone up by 3. So that's the displacement that we're going to be using in SUVAT. I suppose it should be RUVAT since we're using R for displacement. So we need a displacement here. So that's going to be, let me write it in I and J to save a bit of space. So negative 4.5I plus 3J. That displacement took 3 seconds. The acceleration we have is negative or I minus 2J. And is there anything else that we have? Well, we don't need anything else really. We've got 3 things to find the fourth, and the fourth is U. Okay, so that's what we need to find, and I'll call that xi plus yj. So now I can form a SUVAT equation, and that's going to be S equals ut plus half at squared. Now I'm going to be using columns throughout, just find it easier, and I guess I should use R here. Right, so what do we have? Negative 4.53 is equal to U, so that's going to be xy times by t, that's 3, plus half, and a, that's 1, negative 2, times by 3 squared. So from that we get negative 4.53, and then equal to, and I'll do the whole top row and the whole bottom row, so I'll have 3x at the top, and then I'm going to find half of this and then multiply it by 9, so I will have plus 9 over 2 at the top, and then at the bottom I'll have 3y, and then let's see, this will be half of negative 18, so negative 9. So from here I get 2 equations. Negative 4.5 is equal to 3x plus 9 over 2. Okay, so I'll use that to find x. So I'll get 3x is equal to negative 9, which means that x is equal to negative 3. Then for the bottom row, I will have 3 is equal to 3y minus 9. I can add 9 to both sides, so I'll get 3y is equal to 12, and that gives y is equal to 4. So my final answer is going to be that this initial velocity u, and I'll write it in ij form, that's what they gave us, and I can do it in ij form or column form, and that's going to be negative 3i plus j. Let's just underline the u. Question 7. A particle P moves under the action of a single force in such a way that at time t seconds, where t is greater than or equal to 0, its velocity v is given by v is equal to t squared minus 3ti minus 12tj. The mass of P is 0.5 kg. Let's start highlighting some things. So the mass is 0.5. Here we've got the velocity, and what we need to do is find the time at which the magnitude, the size of the force acting on P, is 6.5 newtons. Okay, so anytime you see a question and you've got a mass and it's talking about a force, you know that's going to be F is equal to ma. We've got vectors, so the force is going to be a vector and the acceleration is going to be a vector, and this question says here that the size or the modulus of that force is 6.5 newtons. So the first thing we want to do is to find the acceleration, And we get the acceleration by differentiating the velocity with respect to t. So that will give us 2t minus 3i minus 12j. So there's our acceleration. So if I do F equals ma, then I will have the force is equal to 0.5, and I'm going to write the acceleration as a column vector. So it's 2t minus 3 minus 12 at the bottom, and if I work that out, I'll get t minus 3 over 2, or 1.5 minus 6. Right, now I know that the size of this, the magnitude of this, is 6.5. So the magnitude of this vector is equal to 6.5. Now how would we find the magnitude of the size of this? We would do Pythagoras. So that's going to be t minus 3 over 2 all squared plus negative 6 all squared. The square root of that, all of that, is going to be equal to 6.5. So next step would be just to square both sides. So if we do that, what we'll have is t minus 3 over 2 all squared plus negative 6 squared is 6.5 squared, which is 42.25. Right, let's simplify all of this. Let's expand the brackets. So if I do that, I will get t squared, and then t times the 3 over 2 and 3 over 2 again, so minus 3t, and then plus 9 over 4 plus 36, and let's move over to 42.25. That will all equal to 0. And then what I'll end up with is t squared minus 3t, and then all of these numbers put together becomes minus 4 is equal to 0. That's easy enough to factorise. So I'll have t, so it's going to be 1 and 4, isn't it? So minus 4 plus 1, that works. So that gives me t is equal to negative 1, t is equal to 4. So it can't be negative 1, because we've been told in a question up here that t is greater than or equal to 0. So that just leaves t equals 4 seconds. So that's the time when the magnitude or the size of the force is equal to 6.5 newtons. Question 8. A small box of mass 3 kg, so that's going to be that little box there. Let's write a little 3 on it. Here we go. Moves on a rough plane which is inclined at 20 degrees to the horizontal, 20 degrees there. The box is pulled up the line of greatest slope of the plane using a rope which is attached to the box. So I know that it's going to be moving in that direction. That may be moving at constant speed or accelerating, we'll see. The rope makes an angle of 30 degrees as shown in the diagram. Here we go. The rope lies in a vertical plane which contains a line of greatest slope of the plane. The coefficient between the box and the plane is 0.3. Let's write that down. So mu is 0.3. And the tension in the rope is 25. So let's put 25 newtons there for the rope. It's pulling up. The box is modelled as a particle. The rope is modelled as a light, inextensible string, and the air resistance is ignored. Using the model, find the acceleration of the box. Now I know it's accelerating. So it's going to be accelerating up the slope. I want to find A. So the first thing I want to do is to put on all of the forces on this diagram. So I have down here the weight 3g. Then I have a normal reaction up here, R. Then because it's being pulled up the slope, I'm going to have a frictional force here, mu R, or I can use F. Then I need to deal with forces which are not running parallel perpendicular to the plane. So that means this 25 newtons in the rope, I need to find the parallel and perpendicular components of that to the slope. So the one running parallel to the slope will be 25 cos 30. So 25 cos 30 here, and perpendicular to the slope 25 sine 30. And then we need to do the same with the weight, those two bits which are not running parallel or perpendicular to the slope. So we'll find these two bits here. This angle at the top here, that's the same as the 20. So my force, which is perpendicular to the slope, will be 3g cos 20. And this one down here running parallel to the slope will be 3g sine 20. Okay, so the first thing you're going to do is to look at the forces which are perpendicular to the slope. So we're going to be resolving in this direction. Those forces will be balanced because the particle's not moving this way, it's accelerating parallel to the slope. So what have we got going up? So up we have the normal reaction, R. Anything else going up? Yep, the 25 sine 30, and that's going to equal the force going down, which is the 3g cos 20. So 3g cos 20. Okay, I guess I could rearrange that for R. So R is equal to 3g cos 20 minus 25 sine 30. Right, now we're going to resolve parallel to the slope. Now these forces are not balanced because it's accelerating up the slope. So when we do that, the forces going up the slope are going to be bigger than the forces going down, and it's going to be F equals ma. So up we have 25 cos 30, 25 cos 30 going up. There are no other up forces. The opposing forces are going to be 3g sine 20, so minus 3g sine 20, and minus the mu r. Now mu is 0.3, so 0.3 r is equal to ma, and the mass is 3, so 3a. Now you can see that we can take our value of r here, and that can be substituted straight into this equation here. So let me write out what that equation is going to be, and then I can solve it all in one go on my calculator. So A is equal to 25 cos 30 minus 3g, that's 3 times 9.8 sine 20, minus 0.3 times by r, so that's the 3g cos 20, I'll run out of space here, minus 25 sine 30. Okay, and then all of that we want to divide by 3, or I could just put a third in front. So let's do all of my calculator and see what I get. Right, so I get 2.35238 and so on. Now, on a question like this, you must definitely round to 3 significant figures or 2 significant figures. So you'd want to give your answer as 2.35, or to 2 significant figures 2.4. So this is the only time you would be allowed to round to 2 significant figures and not be penalised, and that is when you're using g equal to 9.8 in your question. But if you always round to 3 significant figures, you're always going to be fine in terms of giving an answer. Part B. Suggest one improvement to the model that would make it more realistic. Now there are several things we could write down. I'll write down a few. So we could use a more accurate value for g, because the value for g we're using at the moment is just two significant figures. 9.8 could be 9.81, or even more accurate. The rope we modelled as being light and inextensible. Now, it may be more accurate to include the mass of the rope or weight. It may be that the rope is slightly stretchy, so as you pull it, you have to pull it a bit before it moves, so it may not actually be inextensible, so it may be slightly elastic. So we could model the rope as being, I'll just put slightly elastic, it's not going to be a lot, slightly elastic, or slightly extensible you could use. Also in the question it said that we ignored air resistance, so we could include air resistance in our more realistic model, so include air resistance. There may be others, but they're the main ones I can think of. Part C, the rope now breaks and the box slows down and comes to rest. And what we need to do is to show that after the box comes to rest, it immediately starts to move down the plane. So if the rope breaks, this force here is all gone. Now I can't rub it out with white, so let's just do that. So we're going to ignore all of that. That's no longer there. There are forces which are still there though, so there's still a normal reaction. The weight is still there, 3G, and we want to know whether it's going to slide down, in other words move in this direction, which means this time the friction is going up. Here is our mu r. Okay, so this time the only component we need to find are these two. So we've got 20 degrees here, and then we have 3G cos 20 and 3G sine 20. Okay, now if it's going to move down the plane like this, it means that those downwards forces have to be greater than the upwards force. So now the only downward force is 3G sine 20. For it to slide down, that needs to be greater than the force going up, which is mu r. Now we know that mu r is going to be the coefficient of friction, which is 0.3 times by r, and r is going to be 3G cos 20, so 0.3 times by 3G, 3 times 9.8 cos 20. Now 3G sine 20, that works out to be 10.055 and so on. Then we'll work out this on the other side, the mu r, and that's 8.288 and so on. Now I can see that that is greater than that, so I can put something like, since 3G sine 20, and I've showed it in my working, is greater than 0.3 times by 3G cos 20, the box will move down the plane, which is what we were expecting. So I guess the important bit is actually showing that this value is greater than this one, and we did that in our working here. Another way you could do it is to do the 3G sine 20 minus mu r and show that that's greater than 0, and that basically shows that there's an acceleration, force is not balanced. So this force is a greater force, it's a bigger force than the resistive force, so then it will slide down. Question number 9. A beam AB of mass 20 kg and length 3 meters is smoothly hinged. Okay, so we've got a smooth hinge here to a vertical wall at one end A. The beam is held in equilibrium in a horizontal position by a rope of length 1 meter. Okay, the end of the rope is fixed to a point C on the wall, which is vertically above A. The other end of the rope is fixed to a point D on the beam, so that angle ACD is 30 degrees as shown in figure 2. The beam is modelled as a uniform rod and the rope is modelled as light and inextensible. Using the model, find and in part A the tension in the rope. So the first thing I want to do is to put on the forces here. So I'll put on the weight of the beam, which is 20G. It's a uniform beam, so that means that the centre of mass is at a distance of 1.5 from the either end of the beam. I have a rope here, which I'm going to put tension in, so the tension is going to be pulling away, so we'll label that as T here. And there's also this smooth hinge at A. Now any hinge has a horizontal and vertical part to its reaction, which I'm showing on here. And because this tension here is at an angle, what I want to do is to work out what the horizontal and vertical components of this are. Now that might be a bit tricky, so let me do it up here out of the way. So this is the tension, like that. It'll be a bit tricky to draw it on a diagram. So I've basically got a horizontal, vertical part here. The angle here is 30 degrees. So I have T sine 30 and T cos 30 here. Now, because I want to find the tension in the rope, I really want to form an equation with one unknown. And the best way to do that is to take moments about A. So by taking moments about A, I eliminate the horizontal and vertical reactions here from the hinge straight away, and I just need to form a moments equation. Now my moments diagram is going to look a bit like this. Here's point A. Now I've got a distance of 1.5 meters to the 20G. Now with the tension, I need to find a component of the tension that's acting in a direction that's perpendicular to a distance from the point where I'm taking moments. So that's going to look like this, and that component is T cos 30. So I'll write that down, T cos 30. And I need to know the distance of that component of the tension from the point where I'm taking moments from. So that's this distance here. So I've actually got another right angle triangle. And in that right angle triangle that I've got here, the hypotenuse is 1. So it's going to look something like this. So I've got this triangle here. This is 1. This is 30 degrees. And it's going to be this distance here is the distance I want to find, which is this distance here. And that's going to be 1 sine 30, or just sine 30. So that's that distance there. Right, so now I can take moments about A. So my anti-clockwise moments will be T cos 30, that's the force, times by the distance, which is sine 30, is equal to the clockwise moment, which is 1.5 times by 20G. 1.5 times 20G. Right, let's see what that gives us. Right, so we get T times by root 3 over 4, that's sine 30 times by cos 30, is equal to 30G. So T is going to be equal to 30G, or 30 times by 9.8 divided by what we've just worked out, the root 3 over 4, and we get 678.963. So 2 or 3 significant figures. Because we've been using G, I'll use 3 significant figures, so 679 newtons for part A. Part B, the direction of the force exerted by the wall on the beam at A. So basically we want to find these horizontal and vertical components of the reaction here, and then use trigonometry to work out what the direction is, the combined direction of those two forces. Now I've made an assumption about the directions. They could be in the opposite directions. If so, if the vertical goes down, for example, I should get a negative answer. If the horizontal is going the other way, I'll get a negative. So I'm just assuming they're this way. They could be in opposite directions. The signs of the answers will tell me. So this is where I'm going to resolve horizontally and vertically. So let's start by looking at the forces going horizontally. So what do I have? I've got the H going to the left and the T sine 30 going to the right. So H is equal to T sine 30. Now I just worked out T, didn't I? So if I use the answer button and times that answer by sine 30, I get 339.481 and so on. And then if I resolve vertically to find the vertical component, so what do I have? I've got V going up, and then I've got T cos 30 going up, and that's going to equal the force which I have down, which is 20G. So again, if I try and use the exact answer for T, which I got in the previous section, or at least to a couple of decimal places, and rearrange this for V, I get negative, actually get an exact answer, negative 392. So that's actually telling me that the vertical part of the velocity is acting downwards. The horizontal part I got in the right direction. So this is where I'm going to use trigonometry. So basically I've got two forces, a horizontal one of 339.481 and a downward one of 392, and I want to work out what the angle of that is. So I need to work out what this purple one is. So I'm working out this angle here. So I will want to do the tan inverse of 392 over my 339.481 number, and I get 49.1 degrees. Now I need to say where I'm measuring that from. So that is measured below the horizontal. So it's 49.1 degrees, or you could call it 49 degrees below the horizontal. So don't just say an angle, you need to state where you've measured it from, because somebody else might measure that angle from the vertical. So here we go. Part C. If the rope were not modelled as being light, state how this would affect the tension in the rope, explaining your answer carefully. So the way I would explain it is like this. If it's not light, the tension in the rope is not uniform and increases the further along the rope you go. Now the reason that is because the rope has to support its own mass. If we include mass, you need to think of like almost like little weights along here. We're including the mass of the rope, so it has to support its own mass. So as you go along the rope, the tension would increase. Part D. The rope is now removed and replaced by a longer rope which is still attached to the wall at C, but now attached to the beam at G, where G is the midpoint of AB. The beam AB remains in equilibrium in a horizontal position. Show that the force exerted by the wall on the beam at A now acts horizontally. Okay, so I'll need to adjust my diagram then. So let's take or show what that is going to look like in a different color. So if I do it in red, so what's happening now is here's my rope like this, and the tension is now here. Okay, now if the force exerted by the wall at the on the beam at A here, that was the horizontal and vertical ones we had before for the hinge. If it's only acting horizontally, that means that this vertical one must be 0. How's that possible? Well, if we take moments about G, the point G, then what happens is, and I'll show you in a diagram, so this is the point G here, the midpoint of the beam. Actually, let's draw it a little bit further across so you can see the diagram here. So I've got a distance of 1.5 to the vertical force of the hinge here, because it's now that distance there, 1.5 times by V. The 20G is now acting through that point, so that's not included in a moment. And the component of the tension that is vertical, that's also acting through that point. So that would be T cos whatever this angle is here. Okay, I don't know what that new angle is. Okay, but it doesn't matter because they're acting through the point I'm taking moments about G, so they're not going to be included. The only moment we're going to have taking moments about G is the 1.5 V. Now if that's the only moment and this thing's still in equilibrium and it remains in equilibrium, that means that the 1.5 V must be equal to 0. That's the only way it's going to balance out. So if 1.5 V is equal to 0, there is no vertical component acting at A, so there is only a horizontal component or force, horizontal force exerted at A. That would be better. Horizontal force exerted at A. Question 10. A tennis player serves a ball so as to pass over the net, and that's here. The ball is given an initial velocity of 45 meters per second in a direction which is 10 degrees below the horizontal. The ball is struck at a point O up here, which is 3.5 meters vertically above the point A, which is on the horizontal ground. The bottom of the net is at point B, which is on the ground, and A to B is 12 meters. The height of the net shown is 1 meter. The ball is modelled as a particle moving freely under gravity. The ball passes over the net at a point which is vertically above B. Using the model, find in centimetres the two significant figures, the distance between the ball and the top of the net as the ball passes over the net. So the path of the ball is going to be something like this. Yeah, that type of thing. So I'm going to put on here the initial speed here, which is 45 meters per second, and we're told that that is 10 degrees below the horizontal. So I have a horizontal and vertical component to my velocity. So it's going to be one here and one here. Horizontally, we're going to have 45 cos 10, and vertically we'll have 45 sine 10. It moves freely under gravity, so I'll have my gravity going down here like this, 9.8 meters per second squared. Now basically what I want to do is to find how much the ball drops in the time it takes for the ball to travel 12 meters horizontally. So we're going to work out that time. So horizontally the speed is constant, speed, distance and time. I want to find the time that it takes to move 12 meters horizontally, so that's my distance, and the speed is going to be the horizontal velocity, which is 45 cos 10. 45 cos 10. I'm going to leave it like this. I'm not going to work that out, because that I'm going to put into suvat vertically, and I'm going to take downwards as positive since the initial velocity is down. I want to work out the displacement from this height of 3.5. The initial speed is 45 sine 10. Don't care about the final velocity. A is going to be 9.8, and t, well, t is just this here, 12 over 45 cos 10. So because of what I've got here, I'm going to be using S equals ut plus half at squared. So S, which is what I'm trying to find, is equal to u, 45 sine 10, times by t, and t is 12 over 45 cos 10. Let's get that right, 45 cos 10, ut plus half a. Now half of a is going to be 4.9, so just put that in, t squared. So that's going to be 12 over 45 cos 10 all squared. Now that gives a value of S of 2.4752, so on. So that is how much it's dropped from 3.5. So if I do 3.5 minus that, 2.4752, that gives me 1.02479. Okay, so that's how far it is. Now the net itself is 1 meter, so compared to 1 meter, I can see that it's 0.02479 meters above the net. You could just take 1 away from this answer. I need to convert that to centimeters, which means that I need to times it by 100. That will give me 2.479 centimeters. Now it says that we need to give our answer to 2 significant figures, so that will be 2.5 centimeters above the net. So that's a pretty good hit of this tennis player. If they can hit a ball and it just flies over the net at 2.5 centimeters above the net, that's pretty good. Part B, find to 2 significant figures the speed of the ball as it passes over the net. Now to find the speed of the ball, we need the horizontal and vertical parts of the velocity of the ball as it gets to this point here. So we already know the horizontal, that's constant, that doesn't change. So that's 45 cos 10. So with 45 cos 10 and another number, we're going to be doing Pythagoras. So let's work out now the vertical part of the velocity. So this is where we're going to use suvat, where we want to find v, the vertical part of the velocity. U is 45 sine 10. I'm taking downwards as positive. A is going to be 9.8. and t is going to be the time it gets to the net. So we worked that in the previous part. So the time was the distance 12 horizontally divided by the speed, which is 45 cos 10. So we have u, we want to find v, and a is a and t, so we've got v equals u plus at. We'll just plug those values in. So v is equal to u 45 sine 10 plus 9.8 times by 12 over 45 cos 10. So that will give us v equal to 10.46781, so on. I want to find the speed. So the speed is going to be equal to the square root of the horizontal part, 45 cos 10, all squared, plus the vertical part, which is this 10.467 number, all squared. And let's see what that gives us. So we get 45.535 and so on. We need to give a number which is correct to two significant figures. So we can write down an answer of 46 meters per second squared. So there's our speed. Pythagoras done on the horizontal and vertical parts of the velocity. Part C. State two limitations of the model that could affect the reliability of your answers. Okay, so I've stated a few here. So we've ignored air resistance. That's important on this type of question. Tennis ball, any type of ball. The spin of the ball has been ignored. Spin has a big effect on how these things go through the air. So look at a tennis player, things like top spin and things like that. That affects the ball as it's going through the air. The size of the tennis ball, yeah, if they're using a larger tennis ball, I mean they're all a standard size, but if it was larger or smaller, that's going to affect our answer in terms of where the ball is going to end up. And wind as well, yeah, unless they're playing inside and it's a completely closed, enclosed stadium, for example, then wind's going to have an effect as well. I know when it gets too windy, they stop play. And to a smaller extent, maybe things like humidity may affect it as well. I'm no expert in these things, but you know, you want to give some sensible answers. Don't always give answers like a more accurate value of G. Think about the context of the question and relate that to what you know about these things in real life.